And so the first thing we're going to cover here with group operations is called group by. And this is where we can group series uh, or data frames using a series of columns or a mapper, um, which is like a dictionary or a key function to apply this function to a group and return uh, as a series. So this is a kind of a two-step process. So first you take your data frame and you apply this group by function using a certain column, and this creates a group by object, and then that group by object you can apply different functions or mappings to it to do something with it. So if we say comp equals df.groupBy computer OS, this will be a this comp is now a pandas group by object. Then we can apply some functions. So we can do comp dot mean, and this will give us the mean of all the values. All of it automatically only will consider the numerical values grouped by computer OS. So our index is now in this resulting data frame, which is this totally new object that we just created, has 3 rows, one corresponding to each of the computer types, and then 6 different columns corresponding to the score or the experience level of the students for those values. So we could have done sum, or we could have done, let me see if this works. Count would be a useful one. You can see how many answers we got. So it looks like everyone answered the question for each computer type, etc. Or we can get the as usual, I'm going to update the notebook after class, so if you can follow along, or you can, if we wanted the standard deviation, we can get the standard deviation. So we're basically taking this object and then applying this thing. Whatever we want to do, we can apply different functions to it, and it will always group by what we set it to group by. We can have a multi-index object too. So I've done here 2 new things. So we can group by multiple columns, and we can apply a function inline. So I've grouped by computer OS and what score they rank themselves as their level of bash experience. And then it's the same thing. So we can then see, in this case, it's the mean. So actually, there's a third thing, and we can save it as a new data frame. So we've now provided 2 different things to group by. So we get this hierarchical or multi-level index of our data frame. We can apply the mean function straight away, right? Because this thing was just this just generates this object in Python. So we can either save that as a group by object, or we can just apply the function straight away and not even save the group by object. And then we can store that whole thing as a data frame. So this is now a new data frame with a hierarchical index. And we can see that by typing comp bash.index, and you can see it's a multi-level index that has 2 different levels with these names and these labels. Now, if we don't want the columns that we're grouping by to become indexes, we can set as index equals false, and this will instead just generate a numerical index, and these group by columns will just be additional columns in our data frame. So you see the difference. In this case, these are indexes, and you can tell because they're bold, and on the left here they're actually grouped by this gray color, so you can see that they go together. Whereas on the second example, we've just made new columns corresponding to these, and they just happen. You just kind of have to know that where they come from. It's the combination of these two things that represents what values are in here. And so if we look at the index, it's just a numerical index with integers. Questions on that? Okay, if not, then we'll keep going. There's related. I mean, these are all sort of related different ways to shape our data frame or get different information out of it. So the next one we'll cover is called melt. So this is where you can sort of massage a data frame into a format where one or more columns are identifier variables, and the other columns are considered measured variables or value variables, and those are unpivoted to the row axis. So you end up with just two columns, one with the variable and one with the value. So we're going to go back to our data frame here, and we're going to run this melt command. So this melt is a function of pandas. So it's some of these functions, the ones we'll see in a minute, are applied directly to a data frame. So df dot blank. In this case, it's pd dot melt. And then the first argument is the data frame. You then pass a list of identifier variables and a list of value variables. So in this case, the identifier variables will be whether the student has a computer and what kind of computer OS it is. And then the value variables will be these score columns. So when we melt that, we get one row corresponding to every combination of the identifier and value variables. So basically we have everything from score bash to score R, and then we have these identifier variables, and then these are the value variables. So it's taking these were formerly, so we have these two were column headers, and they're still column headers in our new melted data frame, but this variable column now contains the column headers from before, and then the value of that column for that combination of individuals. And yeah. So we can then take that. So basically, we're taking this this data frame and converting it to this long form table where we have the different combinations of identifiers and variables and then the values that correspond to those. So one of the takeaways from this is that so we save this data frame as df_melted, and then this allows us to plot it in a very handy way. So what we're showing here is a point plot. This is effectively a kind of a box plots that are connected to each other. And what it allows us to do is to set the x-axis as the variable, y-axis as value, and then hue as computer OS. And this would not have been possible with the data frame as it was structured before. But by melting it into this format, we can instantly feed it into the point plot function of Seaborn and get this sort of summary of the distribution of each combination of computer OS and each of these scores. And then there's one other thing that I did here was where I just rotated the x-ticks so they are sort of to the side and you can read them a little bit better. You could do 45, maybe looks a little better. But if I had not done that, you can see they overlap, right? So by default, it kind of isn't very smart about how it plots those labels. So by rotating them, we get a nice looking plot. So very quickly, that is melt.